Welcome back to Arfi Tutorials. Before we begin, if you are new here, I highly recommended watching the previous video where I explain DNS in detail because DNS is a key part of how the web works and it directly connects with what we are going to learn today. In this video, we'll be doing a complete beginner friendly walkthrough of the HTTP in detail. HTTP is the foundation of all web communication, and if you want to get into bug bounty, pentesting, or cybersecurity, understanding HTTP properly is absolute essential. I'll explain each concept step by step so you can clearly understand how browser requests data and how server respond. So let's start with HTTP, which stands for Hypertext Transfer Protocol. Whenever you type a website address into your browser and press enter, HTTP is what allows your browser to talk to the web server. It was created by Tim Berners-Lee and his team in the early days of the internet between 1989 and 1991. HTTP defined a set of rules that control how data is requested and delivered over the web. This data can be anything that makes up a website, such as text, images, video, or other content. Without HTTP, your browser and web server wouldn't be able to understand each other. Now let's talk about HTTPS, which stands for Hypertext Transfer Protocol Secure. HTTPS work the same way as HTTP, but with an important security upgrade. In HTTPS, the data exchange between your browser and the server is encrypted. This means that even if someone tries to intercept the communication, they wouldn't be able to read or modify the data. HTTPS also helps verify that the website you are visiting is genuine and not a fake website pretending to be the real one. Because of these security benefits, HTTPS is now the default and recommended protocol for websites on the modern internet. Now let's answer these questions. What does HTTP stands for? It stands for Hypertext Transfer Protocol. What does the S in HTTPS stands for? Here is the answer: secure. On the mock web page on the right, there is an issue. Once you found it, click on it. What is the challenge flag? For this, I will click here on View Site. Click on this. I have got the flag. Let's copy it and paste it. So we have completed task 1. Now let's move to the task 2. When we open a website in a browser, the browser doesn't magically show the page. Behind the scenes, it first needs to contact a web server and request different resource. This resource include things like HTML files, images, and other content required to build the web page. To do this properly, the browser needs clear instructions about where these resources are located and how to access them. This is where URL becomes important. A URL stands for Uniform Resource Locator. A URL is the address of something on the internet. If you have ever typed a website name into the address bar, you have already used a URL. A URL tells the browser exactly how to reach a resource, which server to connect to, and what data to request. Think of it as the detailed instruction that guides your browser to the right place on the internet. A URL is made up of several parts, and each part has a specific purpose. The first part is called the scheme. The scheme tells the browser which protocol should be used to access the resource. Common scheme include HTTP and HTTPS for websites and FTP for transferring files. The scheme decides how the communication between the browser and the server will work. Some URL may also contain user information such as a username and password. This is used for service that require authentication before access is granted. Although this feature exists, it is rarely used today because it can be unsafe to expose login details in the URL. Next is the host. The host is the domain name or the IP address of the server you want to connect to. This tells the browser which server on the internet is store the resource you are trying to access. After the host comes the port number. The port number specifies which service on the server the browser should communicate with. For example, websites usually use port 80 for HTTP and port 443 for HTTPS. While these are the default ports, server can use any port number between 1 and 65535. The path comes next. The path points to the specific file or location of the resource on the server. This could be a web page, a folder, or an endpoint that the server understands. It helps the server know exactly what content the browser is asking for. A URL can also include a query string. The query string is used to send extra information to the server. For example, when you see something like $ID equals 1 in a URL, it means the browser is requesting specific data such as a particular blog post or item. The last part of a URL is the fragment. The fragment is used to jump to a specific section of a web page. This is specially used for long pages where you want to open the page directly at a certain point. The fragment is handled by the browser and is not sent to the server. Once the browser understands the URL, it can make a request to the web server. In the simplest form, a request can be just one line asking for a resource. However, modern websites need more information to work properly. This extra information is sent using headers. Headers are used to provide additional details about the request, such as which browser is being used or which website the request came from. These details help the server respond correctly. In later tasks, we will explore headers in more details and understand why they are so important for how the web works. Let's answer few questions. What HTTP protocol is being used in the above example? Here is the answer. What response header tells the browser how much data to expect. By content length, it is decided. Now, let's move to the task 3, HTTP methods. HTTP methods are used to tell the web server what action the client wants to perform. When your browser sends an HTTP request, it doesn't just ask for data randomly. It clearly specifies what it wants to do. And this is done using an HTTP method. There are many HTTP methods available, but in real world scenarios, you will mostly work with a few common ones, especially GET and POST. The GET method is used when the client wants to retrieve information from a web server. Whenever you open a website, load a page, or click a link, your browser usually sends a GET request. This method is only meant for reading data and does not change anything on the server. Because of this, GET requests are commonly used to fetch web pages, images, and other public resources. The POST method is used when the client wants to send data to the web server. This usually happens when you submit a form, log in to a website, or upload information. A POST request sends data in the request body, allowing the server to process it and often create new records, such as user accounts or comments. Unlike GET, POST is used when data needs to be securely handled and processed by the server. The PUT method is used to update existing information on a web server. When a client sends a PUT request, it is telling the server to modify or replace data that already exists. This method is commonly used in APIs where updating user details, changing settings, or editing store information. The delete method is used to remove information from a web server. When a delete request is sent, the client is asking the server to delete a specific record or resource. This method is also commonly seen in APIs, such as when deleting a user account or removing an item from a database. Understanding HTTP methods is very important because they define how data is accessed and modified on a website. Many security issues and vulnerability exist because HTTP methods are used incorrectly. Learning how these methods work give you a strong foundation of web development, web security, and bug bounty hunting. Let's answer few questions. What method would be used to create a new user account? Post. What method would be used to update your email address? Put method. What method would be used to remove a picture you uploaded to your account? Delete method. What method would be used to view a news article? Get method. Now let's move to the task 4, HTTP status code. In this task, we will learn about HTTP status code. Whenever a web server responds to an HTTP request, the first line of the response includes a status code. This status code tells the client whether the request was successful, failed, or need to take some other action. In simple terms, HTTP status code help the browser understand what happened to its request and how it should be handled the response. HTTP status code are grouped into 5 main range, and each range represents a different types of outcome. The first range is from 100 to 199, which is used for informational responses. These codes tell the client that the server has received the first part of the request and that is should continue sending the rest. These status codes are not very common today and are rarely seen in normal browsing. The next range is from 200 to 299, which represents successful response. If you see a status code in this range, it usually means everything worked as expected. The server understood the request, processed it correctly, and returned the request data. Status code in the 300 to 399 range are used for redirection. These codes tell the browser that the requested resource has moved to a different location. This could be another page on the same website or a completely different website. The browser automatically follows this redirection without the user needing to do anything. The 400 to 499 range is used for client-side error. These status codes indicate that something was wrong with the request sent by the client. This could be due to missing information, incorrect parameters, or trying to access a resource without proper permission. Finally, status code in the 500 to 599 range are server-side error. This means that the request was valid, but the server failed to process it due to an internal issue. These errors usually indicate a serious problem on the server and are not caused by the client. Now let's look at some common HTTP status code that you will frequently encounter. A status code of 200 OK means the request was completed successfully and the server has returned the request content. A 200 created response means a new resource has been successfully created, such as a new user account or a new blog post. A 301 moved permanently status code tells the browser that the requested page has been permanently moved to a new location. This is commonly used when websites restructure their pages and search engines are informed to update their records. A 302 found status code is similar, but it indicates a temporary redirection, meaning the original location may be used again in the future. A 400 bad request response means that the server could not understand the request because something was wrong or missing. This often happens when required parameters are not included in the request. A 401 not authorized status code means that access is restricted and the user must authenticate, usually by logging in with a username and password. A 403 forbidden response means the access to the resource is denied, even if the user is logged in. In this case, the server understands the request but refuses to allow access. A 405 method not allow error occur when the client used the wrong HTTP method, such as sending a GET request to a resource that only accepts POST request. One of the most well-known status code is 404, page not found. This means the requested page or resource does not exist on the server. On the server side error range, a 500 internal server error indicates that the server encountered an expected issue and could not process the request. A 503 service unavailable response means the server is currently unable to handle request, usually because it is overloaded or ongoing maintenance. Understanding HTTP status code is extremely important because they help you quickly identify what went wrong during communication between the browser and the server. For anyone learning web development, cybersecurity, or bug bounty hunting, status code provide valuable clues about how an application behaves and where potential issues may exist. Now let's answer a few questions. What response code might you received if you created a user or a new blog article? 201. What response code might you receive if you try to access a page that does not exist? 404. What response code might you receive if the web server cannot access its database and the application crash? 503. What response code might you receive if you try to edit your profile without logging in first? 401. Now let's move to the task 5, that is headers. In this task, we will learn about HTTP headers. Headers are additional piece of information that are sent along with an HTTP request or response. While it is technically possible to make an HTTP request without any headers, most websites will not work properly without them. Headers provide important context that helps both the browser and the server understand how to handle the communication. Let's first look at common request headers. These headers are sent from the client, which is usually your browser, to the web server. One of the most important request headers is the host header. Many web servers host multiple websites on the same server. The host header tells the server exactly which website the browser is trying to access. Without this header, the server may return a default or incorrect website. Another commonly used request header is the user agent header. This header tells the server which browser and operating system the client is using. Web server use this information to format the website correctly and ensure compatibility. Some website features written using HTML, CSS, or JavaScript may behave differently depending on the browser. So this header is very useful. The content length header is used when the browser sends data to the server, such as when submitting a form or uploading information. This header tells the server how much data it should expect in the request. By knowing the content length, the server can confirm that all data has been received correctly and nothing is missing. The accept encoding header is used to tell the server which type of data compression the browser supports. Compression helps reduce the size of the data being sent over the internet, making website load faster. The server can choose a compression method that the browser understands and send the response in a more efficient way. Another important request header is the cookie header. Cookie contains small piece of data that helps the server remember information about the user, such as login session or preference. These cookies are sent back to the server with each request, allowing the server to recognize returning user. Now let's look at common response header. These headers are sent from the server back to the client after processing a request. One important response header is setCookie. This header is used by the server to store information in the user browser. Once stored, this data sent back to the server with future requests using the cookie header. The cache control header tells the browser how long it should store a response in its cache before requesting it again from the server. Proper caching improves performance by reducing unnecessary requests and speeding up page load time. The content type header is one of the most important response header. It tells the browser what type of data is being returned, such as HTML, CSS, JavaScript, images, PDF, or video. Based on this header, the browser knows how to correctly process and display the content. Finally, the content encoding header tells the browser which compression method was used on the response data. This allows the browser to decompress the data properly before displaying it. Compression helps save bandwidth and improve loading speed, especially on slower connections. Understanding HTTP header is essential because they control how data is sent, received, and processed on the web. Many web security issues and misconfiguration are directly related to headers, making this knowledge extremely valuable for web development, cybersecurity, and bug bounty hunting. Let's answer a few questions. What header tells the web server what browser is being used? Answer is user agent. What header tells the browser what type of data is being returned? Answer is content type. What headers tells the web server which website is being requested? Answer is host. Now let's move to the task 6, that is cookie. In this task, we'll learn about cookies. You have probably heard of cookies before, and at a basic level, a cookie is just a piece of data that gets stored on your computer by a website. Cookies are created and saved when a web server sends a setCookie header to your browser. Once the cookie is stored, your browser automatically sends that cookie back to the server with every future request to the same website. Cookies are important because HTTP itself is stateless. This means that the server does not remember anything about your previous request. Every request is treated as a brand new interaction. Cookies solve this problem by allowing the server to recognize you. Using cookies, a website can remember who you are, store your preference, track whether you have visited the website before, or keep you logged in. The diagram shown in this task helps visualize how cookies work. When you first visit a website, the server sends a response along with a set cookie header. Your browser stores this cookie locally. From that point onwards, every request your browser makes to that website, including the cookie data, this allows the server to link multiple requests together and treat them as a part of the same session. One of the most common used of cookie is website authentication. When you log into a website, the server does not usually store your password inside a cookie. Instead, it's generate a token. A token is a unique and secret value that represent your logged in session. This token is stored in the cookie and sent back to the server with each request, allowing the server to confirm that you are authenticated without exposing sensitive information. Now let's look at how you can view cookies in your own browser. This can be done using the developer tools built into modern browser. If you are unsure how to open developer tools, TryHackMe provide a guide that you can access using the view site option in the task. Once the developer tool are open, you need to navigate to the network tab. This tab shows all the requests your browser makes when loading a website. Each request can be clicked to see detailed information about what was sent and received. If your browser sent cookies with a request, you will find them listed under the cookies section of that request. Learning how cookies work and how to view them is very important for understanding how websites manage user sessions. From a security perspective, many vulnerabilities are related to cookies, such as session hijacking or insecure authentication. This task helps build a strong foundation for understanding both web functionalities and web securities. Now let's answer this question. Which header is used to save cookies to your computer? Answer is set hyphen cookie. Now let's move to the task 7, making request. Click on the view site button on the right. This is an emulator for making demo HTTP request. Using what you learned from the above task, you can use it to complete the below questions. Let's click on the view site. Make a get request to /room page. Here is the flag. Make a get request to /blog page and set the ID parameter to 1. Here is the flag. Make a delete request to /user/1 page. Here is the flag. Make a put request to /user/2 page with the username parameter set to admin. Here is the flag. Make a post request to /login page with the username of THM and a password of let me in. Here is the flag. And that's bring us to the end of the HTTP in detail module from TryHackMe. If you are following along on Arfi tutorials, you now have a strong foundation in how HTTP works, including request, response, URL, headers, methods, status code, and cookies. This knowledge is critical for anyone serious about bug bounty hunting, penetration testing, or web security. Make sure you practice what you learn by analyzing HTTP traffic and completing more labs. In the upcoming videos, we'll continue building on these fundamentals and move deeper into real world web security concept.